it's me, Mrs. Nolte, your numbers navigator, and today we're going to talk about the area of quadrilaterals, parallelograms, rectangles, and squares. And basically all of those are quadrilaterals because a quadrilateral is a four-sided figure, okay? So the first thing we're going to do is we're going to talk about some definitions, okay? So I'm going to go ahead, and I have a special pin here. Haven't used it in a while, so we'll see how it goes. Okay, so the first thing I'm going to talk about is some definitions that we need to know for today. Okay, and don't panic if you don't understand the definition the first time you see it, because I'm going to show you examples with the drawings as soon as I get the definitions explained. So the first thing you're going to see is a closed figure formed by three or more straight lines. This is called a polygon, and a polygon basically is something that has to be closed in. And closed means it's complete, and it has to have three or more straight lines. Let me give you an example, like a triangle. Well, not that little piece there. Or maybe a square. But a shape like this cannot be because it's not closed, it's not connected, and it's got curves. So a circle, for example, is a closed figure, but it's not a polygon because there's not three or more straight lines. So something like this could be a polygon because it's just got lots of straight lines in it. Okay, pretend that's not a curve, okay? But you get what I'm trying to say. A straight lines and they're connected, okay? A quadrilateral, like I said, is a four-sided figure. So there's lots of quadrilaterals with lots of different little rules. Your first thing I'm going to tell you about a quadrilateral with four opposite sides that are parallel and opposite sides the same length, that's called a parallelogram. So that's kind of easy to remember because it's got the word right in the definition. So this is called a parallel, I always spell this wrong, parallelogram. I've never been good at spelling, so I teach math. So a parallelogram, like I said, has two sets of parallel lines, okay, and opposite sides the same length. I'll explain what that means more in a minute with pictures. The next one is a parallelogram. So this is kind of like they're all connected. It's almost like a family tree, you know, like here's something and it branches out and it branches out. Like they're all connected, but they're not all the same. This one's called a rhombus. So a rhombus is a parallelogram with four equal lengths. So it's kind of like a square, but it's a rhombus. It's shifted, and I'll talk about more what that means in a second. The next thing we're going to talk about is a base. A base is any side of a parallelogram. You're going to need to know that for when you calculate the area of that shape. Okay. The shortest distance from the base of a parallelogram to its side will be the height. Okay. And the last thing that I'm going to talk about today is an equation that shows a relationship among certain quantities is a formula. Now, you definitely need to use a formula for geometry. And some formulas they actually give you on tests, but in this particular situation, 6th grade content, they usually don't give you the formula. They usually expect you to memorize it because they're smaller formulas. But as you get older, they get really long. Sometimes they don't have you. They'll give you like a formula sheet. So then you have like a cheat sheet to help you, if you know what I mean. Okay, now, before I move on, I want to tell you I'm going to draw some pictures of these, okay? Don't panic if you're confused. I always hated it when my math teacher would go over something and she'd be like, okay, do you get it? And she didn't have any pictures or examples. It's okay if you don't get it yet. Don't panic. Oh, there we go. Okay, let me click that. So the next thing we're going to do is we're going to draw some shapes, and I'm going to better explain what these mean. So like I said, a polygon has to be a closed-sided figure, okay? Has to be closed-sided. So that means closed, no roundness, has to have at least three straight lines. A parallelogram looks like this. It's got two sets of parallel lines. So parallel lines means that it goes on forever and they never connect. So see these little arrows kind of mean, that's what they mean. They mean parallel lines. Parallelogram also has height. Now this cannot be the height because it's not straight. It's crooked. Hello, it's got to be straight up and down. So this is a straight up and down height. So anytime you see a parallelogram and they try to put a number right here, which does you all the time. So they'll put it right here. Kids get tricked by it. That's not the height. The height is vertical. So you need to find that right angle. So this is going to be my height. Okay, I'm going to talk more what that means in a minute. So don't get hung up on what's the height. I don't understand. Next is a square. We all know what a square is. So that's it's got equal sides. So a rhombus is kind of like a parallelogram and a square pushed together. So it has equal sides But, oh, sorry, this one's that one doesn't look very good. Let me erase it. Hold on. I'll erase that. Now I'll erase this and give us some more space. So a rhombus is basically a mini parallelogram. See how it's kind of slanted? And technically, if you want to get technical, a square also has two sets of parallel lines as well. But it's not kind of sideways, right? That's what the rhombus is doing. It's kind of going sideways. So this is my rhombus. I'll put an R for rhombus. This is my P parallelogram. This is an S for square. And we all know a rectangle, right? So a rectangle is kind of more like a parallelogram, but it's not like the crooked thing, okay? Yeah. So these are quadrilaterals that I'm talking about today. And all of these quadrilaterals can use the same formula to calculate the area. And when you calculate the area, you need to know that A equals base times height. Now, oftentimes when you're doing an equation in math, a lot of people want to do this. So like, let's say you have A plus 7 equals 8. Okay, you know A is 1, right? Well, this technically can never be capitalized. I have a lot of students that want to put a capital A there. Wrong. My people watching should know. Sorry, I'm lagging again. Sometimes that happens. A capital A means area. So if I put a capital in an equation, that's technically not correct. Okay, so A means area in the math world. A capital A. Now, lowercase a, that's totally fine for other things, but in this specific, can't even talk. In this specific example, what I'm showing you, I'm lagging again. You need to understand that area is always capitalized, okay? So the height is always straight up and down, right? So and in the parallelogram example, I told you it has to have a right angle. See, look, right angle, right angle. Now, rhombus, you'd have to find that right angle there. This would be the height. So the height has to be a 90-degree angle, straight. The base is going to be the opposite sides. So the opposite side of the height. So this would be a base. This would be a base. This 3 you don't use, okay? You would not use that. This would be a base. This would be a base. If you don't understand yet, don't panic. We're going to do examples, promise. So all we're going to do is multiply base times height when we do these. Do not panic. This is going to be easy. This is like easy peasy lemon squeezy. Okay. Okay. You know what time it is. It's Millie break. So that's what we're going to do.
Would you like your new football? Oh, look at that. She knows it's for her. Look. This is from the Dollar Tree. Oh my goodness. You got your new, you got your new bandana? Are you ready? Stay. Okay. Go, Millie, go! Bring it here! No, bring it here! Yay! I love my new football! There she goes. Look, she loves it. She's gonna run around with it. How much do you want to bet? There's Mr. Nolte's feet. Go, Mel, go! Get it! Get it, Mel! Look, she's all playing. Now watch if I take it, she'll get mad about it. Drop it. Oh, never mind. Come on. Come on. Let's go. Let's go. Oh, come on. Yeah. I know. Ready? Sit. Stay. Right here. Right here, Mel. Millie, sit. Sit. Show them what you've done. Stay. What did you do to your football, Mel? Millie? Sit. Hey, sit. Show them what you did. Did you eat it? Well, I guess you didn't eat it, but stay. I'll throw it, she'll catch it. Stay. Okay. Oh, almost. And the destruction continues.
Okay, I hope you enjoyed your Millie Ann math fan break. I know I did. Just a real quick, before I get started with some examples, I just want to remind you on this here. Let me get this pulled back up. That sometimes people get this misunderstood because all these definitions are almost like intertwined. So like you might say, well, Miss Nolte, a rectangle has parallel lines too, like a parallelogram. A lot of these definitions have very intricate things that are similar, but there's also differences. So for example, this has properties, a rectangle can have properties of a parallelogram, but a parallelogram does not have 90-degree angles. So that's what makes a rectangle different from a parallelogram. So don't let that confuse you. That's why I try to be very basic in this, because there's a lot of things that some of your higher math people might be like, hey, she may not have explained that right. I understand there's higher properties here specifying them, but what makes it a little easier for me to explain to people is the rectangle, imagine your rectangle, and the parallelogram, imagine this, okay? Even though there's some similar properties involved between these two, same with the rhombus and the square and the parallelogram, and there's a lot, it's like I said, it's like a family tree, okay? So like there's like a grandma, and then there branches out to aunts and uncles, like they're all related, very closely related. I remember in school how we talked about this, and I was like mind-blowing, okay? So don't let that confuse you. Try to use my images to help you a little bit, but the beautiful thing is, they all use the same formula, so you can't mess it up, okay? So we're going to do some examples. So I'm going to start with just some rectangles. That's simple, right? We've done this before. Now, you probably heard length times width. I don't like to use length times width anymore. A lot of people, you know, they learn LW. I'm not going to, and I don't use a regular L like this because it looks like a number 1. That's a no-no. So I am not going to use length times width because I think it's bad practice for when you get other formulas that are more difficult, like the trapezoids, triangles, and harder, higher level. So I always teach my students A equals BH because that's something you're going to use for other formulas. So we're going to use A equals BH today. And let's say I have a rectangle here. And we'll go basic. You know, these are all 90-degree angles, of course, because it's a rectangle. And let's just say this is 7 inches and this is 3 inches. Okay? Okay. Guys, I tell my students, we'll plug and chug. We're going to plug it in, chug it to get my answer. All right? So I got A. I got my base is 7. And my height is 3. 7 times 3 is 21. That's literally it. 21 inches squared. Squared represents area, so that's all the stuff inside. Or you could also say square inches. I don't put an X here for my times because it looks like a letter. I've been teaching my students anytime you work with an equation, showing a letter's no good. So I'm going to either be using parentheses or the dot. I actually prefer the parentheses myself because the dot sometimes looks like a decimal place. Okay, let's do another one. Let's say we have, I'll go like this. I'm going to make this one smaller so I have more workspace. This one's 14 feet, and then I'll say this is 23 feet. So the first thing you always do is write your formula. A equals base times height. And my base, oh no, Miss Nolte, which one's my base? Well, here's the beautiful thing about this, okay? Either way, it's fine. I know you look at it vertically, and you think, okay, well, this is technically the base, and that's the height. In a rectangle, either way, it's going to be fine. It really depends on how you view the rectangle. Is it sitting like this? Is it sitting like this? They're all right angles. It's going to be fine. So it doesn't matter which one you put first in this particular situation. Now, I don't know how to do that in my head. Maybe some of y'all can. Mr. Nolte could. He's like a genius at math. I'm not like him. He's so good. So, and I want to make sure you know how to multiply. What's 3 times 4? 12. Carry my 1. 3 times 1 is 3 plus 1 is 4. Don't forget to slap your 0. I tell my students we got to slap it in there. 2 times 4 is 8. 2 times 1 is 2. Millie thought somebody knocked on the door. She started barking. Okay, I'm going to add this together. 8, 9, 10, 11, 12. Carry my 1. So this would be 322 feet squared. That would be my answer here. And if you had a calculator, you could just type it in. Okay, perfect. Okay, we got 2 more examples. I'm not going to do any rhombus examples today. A square and a rectangle are actually the same. I just did 2 rectangle examples, but I know you've done squares in the past if you're at this point. So I'm going to do a parallelogram. This one's what confuses a lot of students. So let's say I'll call this 2, we'll call this 3 inches, and we'll call this 8 inches. Now this is where students get stumped. Okay, they don't have to write all these in here. This should be 8, right? Because they're opposite, and this would be a 3 if I wrote it in. But what numbers do I use? Okay, you always use the height with the right angle. So I have to use the 2 as, oops, sorry, my pencil messed up there. That's an equals. The 2 would be my height, okay? Base times height. It's good practice to write your formula. So my height would be 2 because it has the the right angle, and because the other one's slanted. We don't need these numbers. So it'd be 8 times 2, which is just 16 inches squared. Okay? All right, we're going to do one more. Let's say I have another parallelogram here, and let's say it has 18 here, and then it's got 7 here, and then it's got a 52. Miss Nolte, where's my units? We'll see what happens when they don't provide you units. Sometimes they don't. So I'm going to have A equals BH. Once again, it's really good practice to always write down your formula. My base we know is 52, right? There's the bottom. It's not 7. Why is it not 7? Who remembers? Who remembers? Because it's not opposite to the height. It's almost like a T. See? Here's this one. Here's this one. So you have to find the base is opposite of the height. So it has to be right with it. Almost like it has to be like touching it, okay? So I'm going to have my height would be 18 and my base would be 52. And it's okay. We just go to the side and multiply. Don't panic if you're like, oh my gosh, I can't do that. Yeah, you can. 8 times 2 is 16. 8 times 5 is 40, plus 1 is 41. We slap our 0. 1 times 2 is 2. 1 times 5 is 5. Now we will add it. 2 plus 1 is 3. I get 936. And what do I do if there's no units? You say units. I would say units squared. So sometimes they don't provide you inches, feet, or what have you. You just put down what has been given, okay? You can't put down what's given, right? So when I say units, that's what you say in replacement for whatever you don't know, okay? So it's square units, units squared, no big deal, okay? It's that time already. If you have any questions, comments, or any math content that you would like me to do, please let me know, okay? Have a nice day.